Today we are going to start a topic on vectors. Now some of you may have experienced vectors already in physics, but what we are going to do in maths is focus really on what vectors are like geometrically. So what do they look like physically? Okay, so in maths, and for the purpose of what we're doing, a vector is a directed line segment with direction and magnitude. It represents movement or force. So what we have here in this picture is a vector, and it goes from P, the initial position, to Q, the end point. And we have in here, which is probably the most important part, is your arrow, okay? And this is what makes this a directed line segment, because this is telling you you're going from P to Q. And we've also denoted that this vector is the vector V. So over at the side here, we have all the different ways that a vector can be denoted. We can have bold V with an underscore, V with an arrow on top, or we can have PQ with an arrow on top. And that arrow denotes the direction in which you're going. So we've gone from P to Q, our initial position to our end point. And this geometrically is what a vector looks like. So we have an example here. This vector goes from A to B. Now, we've talked about how you notate a vector, but what actually does that notation signify? Okay, and there are two ways to do that. We can either have it as a position vector, or we can have it in component form. And we're going to look at both of these, because how you get the answer to both is the same. Okay, so vectors are irrelevant, unless you have a position vector, vectors are irrelevant to the axis, to x and y axis. So this means that this AB vector here could appear anywhere in space, and it will be the same vector because it doesn't matter where in space it's happening. So rather than donating vectors in relation to x, y, and eventually z, we donate them in relation to I, j, and k. Okay, and then if you take a look here, okay, we just have to focus on I and j just now because we're focusing on 2D vectors. How you work out the number that goes with I is how far along in the typical x direction have you gone. And if we look, we've gone 1, 2, 3. So this would be 3I. And then how far up or down have you gone in the typical y direction? We've gone 1, 2, 3, 4. So that means it would be 4j. And then we don't have a z-axis in this one, so there's no relationship to k. But we can, in the future, have a relationship with k, and we will look at those. So this is actually the vector 3i plus 4j in position vector format. And in generic format, this position vector would be AI plus BJ. And that's the generalized vector format. And then in component form, really straightforward, it is the vector 3, 4. And that's all you're looking for on that one. Okay, it's important to note also with this, the direction in which this is travelling. This is going A to B. Okay, so if we were going to talk about notation, this could be the vector AB. It could be the vector A underlined, or it could be the vector A with its hat on, with its arrow. Okay, all three of those would donate this same vector. Okay, so now we're going to look at the same vector we were looking at before, but this time we're going from B to A. So this is the vector BA. So if we think about it in relation to the other one, then that's going to be the vector negative A or negative A hat, arrow hat. Okay, so that's what this vector is. And how we find those components are exactly the same, except now what we're looking at is focusing more on the direction of travel. So you're going from B to A. So this time you have in fact gone back 3, so it's negative 3. Going from B to A, you have gone down, so you're going to negative 4. And then if we're going to write that in position vector format, it's negative 3I minus 4j. Okay, so the direction that this arrow is going in is really important for telling you how your components actually look, whether they're positive or negative, and how you're actually travelling around space. Okay, so let's draw a vector. This time I want 3i minus 2j. So all I got to do is pick a starting point. So I'm going to start here. Okay, so 3i says that I'm going to go along 1, 2, 3, so I'm now here. And then 2j means I'm going to go down 2, so 1, 2, and I'm here. And then that is my actual vector there, and I've gone in that direction. So that there, just ignore the fact that it's not a straight line, is the vector 3i minus 2j. Okay, so positive and negative numbers are telling you explicitly how your vector is travelling in space. And then final example, this one's in component form. I'm drawing the vector negative 2, 4. So again, I'm just going to pick my starting point. And again, this vector can be started anywhere in space and it will still be the same vector. So negative 2 means that I'm going back 2. So I'm here. And then I'm going up 4. 1, 2, 3, 4. So I'm here. So that means that this is my vector here. And then I'm denoting the arrow to show start point, end point. And that's the vector negative 2, 4. Now when I'm talking about drawing it anywhere in space, I'm talking about I could start here and draw it here. And it would still be the same vector. I could draw it here and I can draw it here and it'll still be the same vector, okay? Every single one of those vectors is the exact same. They are the vector negative 2, 4. They're just appearing in different places within space.